Hello everyone. A very good day to all of you. Today, we from 3 Sigma are going to present to you all a short presentation about Mathematics Form 3, Chapter 1, that is Indices. Our group members are Smita, Kartigaa D, Rashmika, me myself Stephanie, Sivvaani, and Sashthika. Let us proceed to the next slide. So, for example 1, a to the power of n. So basically, a number in index notation is written as shown, a to the power of n. A is called the base, while n is called the index. Secondly, the value of index in an index form is the same as the number of times the base is multiplied repeatedly. So for example, if a to the power of 5, so a will be multiplied 5 times. Let's proceed to the next slide.
Here are a few examples. Example 1. Write each of the following repeated multiplications in index form. As we can see in question A, 8 times 8 times 8 times 8 times 8. Since the multiplication is repeated 5 times, it will be known as 8 to the power of 5. For question B, since 2 over 7 is multiplied by 9 times, it will be 2 over 7 to the power of 9. For example 2, express each of the following as repeated multiplication. Since it's negative 9 to the power of 7, negative 9 is needed to be written 7 times. Question B, p to the power of 4. Since it's to the power of 4, p is to be repeated 4 more times. Example 3, given that k times k times k times k equals to negative 3 to the power of n, where k and n are integers, state the values of k and n. The solution is k times k times k times k, which we all know by now is k to the power of 4, equals to negative 3 over n. Thus, k equals to negative 3 and n equals to 4. Hi Cyrus, do you know how to convert a number into a number in index form?
Yes, Mika, I do know. We can use repeated division method or repeated multiplication method to convert a number into a number in index form.
So let's look at an example for repeated division method. Write 64 in index form using base of 2, base of 4, and base of 8. Firstly, base of 2, 64 is divided repeatedly by 2. As you all know, the division is continued until 1 is obtained. Hence, 64 is equals to 2 to the power of 6. And for base 4, 64 is divided repeatedly by 4, and 64 is equals to 4 to the power of 3. And for base of 8, 64 is equals to 8 to the power of 2. Let's look at another example. Write 32 over 3125 in index form using base of 2 over 5. You have to use repeated division 2 and 5. Hence, 32 over 3125 is equals to 2 over 5 to the power of 5.
Now, let's see how to do repeated multiplication method. Let's see example 1. For example 1, we have to write 64 in index form using base of 2, base of 4, and base of 8 using repeated multiplication method. For A, we have to write 64 in index form using base of 2, where we have to keep on multiplying 2 till we get 64. Then we have to write the number 2. We have to count the number 2. For example, if the number 2 is repeated 6 times, then it will be 2 to the power of 6. That is for the same thing for B, where we have to keep on multiplying 4 till we get 64. Then we have to count a number of 4s. If at all there are 3 number of 4s, then it will be 4 to the power of 3. And the same thing for base of 8. For example 2, we have to write 32 over 3125 in index form using the base of 2 over 5. For this question, we also have to times 2 to the power of 5 till we get 32 over 3125. Hence, 32 over 3125 equals to 2 to the power of 2 over 5 to the power of 5.
Law of indices. These are the formulas used in this chapter.
Students, can you understand and memorize all these 6 laws of indices?
Teacher, can you show us some examples so that we have a clear understanding?
Here are some examples for all the 6 formulas. For formula 1, which is a to the power of m times a to the power of n equals to a m to m plus n. So for a, 7 to the power of 2 times 7 to the power of 3 equals to 7 to the power of 2 plus 3 equals to 7 to the power of 5. For b, 0.2 to the power of 2 times 0.2 to the power of 4 times 0.2 to the power of 5 equals to 0.2 to the power of 2 plus 4 plus 5 equals to 0.2 to the power of 11. And the same thing for the third example. For formula number 2, where a to the power of m divide a to the power of n equals to a to the power of m minus n, where 5 to the power of 4 divide 5 to the power of 2 equals to 5 to the power of 4 minus 2 equals to 5 to the power of 2. For b, negative 3 to the power of 4 divide negative 3 divide to the power of 2 divide negative 3. It equals to negative 3 to the power of 4 minus 2 minus 1. And the answer is negative 3. And the same for the example C. Here are some other examples for formula 3 and formula 4, where for formula 3, a to the power of m in the bracket n equals to a mn. For a, 3 to the power of 4 in the bracket to the power of 2 equals to 3 times 4, 3 to the power of 4 times 2, where the answer is 3 to the power of 8. For formula 4, it states that a to the power of 0 equals to 1. For example, if 2 to the power of 0, it equals to 1. And it also applies the same thing where m to the power of 0, it also equals to 1. And a does not equals to 0. Here are some other examples of formula 5 and formula 6. Formula 5, a to the power of negative n equals to 1 over a to the power of n, where for a to the power of negative 2 equals to 1 to the power of 1 over a to the power of 2. And for formula 6, 343 to the power of 2 over 3 equals to 343 to cube root 3.
Now we will be looking into linear equations. So first of all, let's have a look at two examples that are stated over here. The first equation that's given is 64 x to the power of 1 over 2 equals to 27 x to the power of negative 5 over 2. So how do we solve this? First of all, x to the power of 1 over 2 has to be divided by this variable, which is x to the power of negative 5 over 2. Bring this 2 to the left. Next, 27 over here. So what should we do in order to simplify this further? 64 should be brought to be divided with 27, as in this place, 64 is in the multiplication form. Next, as we have learned in the law, if it's in the form of division, it can be subtracted. So x to the power of 1 over 2 has to be subtracted with negative 5 over 2.
and we will get x to the power of 3, which is also x cubed. 27 over 64 will just be maintained to the next line. Lastly, in order to obtain the answer, x should be cube rooted, and you will get the answer, which is x 3 over 4. The same goes with this equation. 25x to the power of negative 2 over 3 minus 5 over 3 x to the power of 1 over 3 equals to 0. So first of all, what should we do when we come across an equation with a fraction? In order to make the equation more simpler, we can just multiply the whole equation by 3 in order to eliminate the fraction over here. So as I've done this, my new equation will be 75x to the power of negative 2 over 3 subtracted with 5x to the power of 1 over 3 equals to 0. Since 0 is over here and we want to make it an equation, to make the equation more simpler and faster to be solved, we can bring negative 5x to the power of 1 over 3 to the right. So as we bring it to the right, it will become a positive variable. Then we need to simplify it further. The same thing goes. Bring x to the power of 1 over 3 to the left, and it will be divide, because in this part it is in multiplication form. 75 goes under here, and then you need to simplify it to become 1 over 15. Since x to the power of negative 2 over 3 can be subtracted with x to the power of 1 over 3 since it is in division form, we can simplify it and we will get x to the power of negative 1. X to the power of negative 1 is equivalent to 1 over x. Thus, we can change the way that we write this variable here to 1 over x equals to 1 over 15. X multiplied by 1 is x, 15 multiplied by 1 is 15. Thus, this leaves us with the answer x equals to 15. This is a simpler linear equation that we have here. 2 to the power of x multiplied 8 to the power of 3x equals to 4 squared. So how do we simplify this? First of all, we need to make the base same. As you can see here, 2 and 8 are different bases. So in order to make the base same, 8 has to be changed to base 2. So as we change 8 to base 2, it will be 2 to the power of 3. So since there's 3x over here as well, we need to maintain the 3x here. Same goes with 4. Change the base to 2 and you get 2 squared. Then we have to multiply this 2 over here, as it is one of the other law of indices that we have learned. So it will be 2 to the power of x multiplied 2 to the power of 9x equals to 2 to the power of 4. So what you should do next is just take all of the indexes and form an equation. X plus 9x equals to 4, 10x equals to 4, and lastly solve it the normal way. It will leave you with the final answer 205. Same goes with this. 2 to the power of 8 divided with 8 to the power of x equals to 4x. So as you follow the same method, change the base to the same number, it will leave you with the final answer x equals to 8 over 5. Next, we will be moving on to simultaneous equation involving linear equation as well. We're going to apply the same type of method that we have used in the linear equation for the simultaneous equation. So let's have a look at this equation. 4 multiplied 4 to the power of x equals to 8 multiplied y to the power of 8 multiplied to the power of y plus 2, and 9 multiplied to the power of x multiplied 27 to the power of y equals to 1. So first of all, we need to make the base the same. So as you can see over here, I have made all of this in this expression to the same base, which is base 2. Same goes with this. I have made it to the same base, which is base 3. Next, I simplify it and took all of the indices and formed a new equation over here. So the new equation that we have over here is 2 plus 2x equals to 3y plus 6 and 2x plus 3y equals to 0. As I simplified it, I formed another equation, which is equation 1 prime from this equation over here, which is x equals to 4 plus 3y divided by 2. So what I should do next is substitute equation 1 prime into equation 2 in order for me to find the value of y. So as I substitute 1 prime into 2, it will leave me with the final answer y equals to negative 2 over 3. After I had found the value for y equals to negative 2 over 3, I'll substitute this into equation 1 prime over here. So x equals to 4 plus 3 multiply negative 2 over 3 divided by 2.
And finally, as you solve this in the calculator, it will leave us with the answer x equals to 1. Thus, we have solved this simultaneous equation, which is y equals to negative 203 and x equals to 1. Lastly, we are moving on to quadratic equation. It is almost the same as the simultaneous equation, except it's a little bit different as it involves square. The first question here is 5 to the power of x squared divided by 5 to the power of 3x equals to 625. Make all the base the same, and as you can see here, I have made it to base 5. Since it's in division, I can straight away minus it, so it will become x squared minus 3x equals to 4. Since this is a quadratic equation, I have to solve it using this multiplication method so that I can find the value of each of the number. So this is called the cross multiplication method. I have solved it using the cross multiplication method after doing this equation over here. So after solving it with cross multiplication, my answer is x plus 1 multiply x minus 4 equals to 0. The next step that I should do is make another equation from these two in order to find two answers that are suitable to be placed into this question as the value of x. As you can see here, x plus 1 equals to 0. Then my answer is x equals to negative 1. Or x minus 4 equals to 0, and my answer over here is x equals to 4. So both of these answers satisfy the answer for this equation. Next is another example. 9x squared divided by 9 to the power of 5x equals to 9 to the power of 6. So since all the bases are the same, I can just move on to solving the question. After doing cross multiplication over here, I'm left with these two answers, which is x equals to 6 or x equals to negative 1.
Summary. There are two ways to convert a number into index form, and the ways are repeated multiplication and also repeated division. The 6 laws are the most important thing we have to memorize in this topic. In order to solve questions from this topic, we must know how and where to use the law properly.
This is all from us today. Thank you.